So second transformation we're going to look at, well, second and third, are amplitude and vertical shifts. Okay? Both of these transformations are going to affect the y values. Okay? What's nice about changing the y values is the arithmetic today, it's going to be a lot easier. We do have one more transformation we have to do that affects the x's, but that one will be tomorrow. Okay, so it's a total of 4 transformations we're learning. Shifting left and right, shifting up and down, stretching up and down, and the very last one tomorrow is stretching left and right. So first, we'll talk about a concept we didn't really mention yesterday, and that's called the height, or the amplitude of the wave. When we connect this with a sound frequency, changing the amplitude definitely does something to what you hear. I kind of already showed it to you a minute ago, but anybody have a guess what, like that wave in black versus the wave in green, what the difference would be in what you hear? Yeah?
The black one would be higher pitched.
Okay, so the black one, what's one possibility? It could have a different pitch to it. What else can you change about the sound besides its pitch? Yeah?
The volume.
The volume, yeah, and that would affect the volume. So changing the height of a wave changes its volume. If we want to be more general, it changes its intensity. Okay? But with sound, the way you perceive intensity is loudness. If this was a wave that represented light, right? Like a light wave, like color, electro, that kind of wave. We don't perceive intensity of a light wave as volume. You would perceive it as brightness. So different kinds of waves, intensity means different things. Louder, brighter, depends on what you're talking about. But either way, it's more intense. If that was a picture of like an X-ray wave, then that would be a stronger X-ray. Maybe be able to penetrate, deeper into the skin or something, versus a weaker kind of X-ray. So it measures the height, and whenever you measure height's a distance. What do we know about a distance? It's always what kind of number? Yeah?
Positive.
It's always positive. Okay, so you can never have a negative amplitude. Okay? Amplitude is always a positive number, or if you didn't have a wave and it was perfectly flat, well, that would be like a sound with 0 volume. Okay? Then you really don't have a sound anymore. Right? But other than that, the amplitude is always a positive number. Okay, so what does an amplitude change look like? The amplitude change is when you take a number and you multiply it in front. Okay, so 2 things are different about this than yesterday. Yesterday, we did something inside the argument. Okay, today, we're not doing something inside the argument. Whenever you do something right next to the x, okay, the x is called the argument, that's a horizontal transformation. When you do something that's outside of these parentheses, it's a vertical transformation. Depending on what you do, there's 2 different vertical transformations. The first one we're learning is multiplying by a number in front. If you put a 3 in front, it would do exactly what you would expect. It would make the wave 3 times as big. Just show you a quick sketch on the calculator, or I'll just do it by hand. Either way. So let's say that was your original wave. If you stretched it 3 times as much, it would be like up there and maybe about down there. I'm just kind of estimating. Okay. The red wave would be a louder sound. If you do something like a half, that would make it quieter. Okay? That would take your wave and it would compress it. Something more, it's not perfect, but something more like that. Now, when you put a negative, the negative also does something else. Does anybody remember from other function we studied earlier in the year, when you put a negative in front, The negative causes the graph to do something. Yep. Causes it to flip. Yep. So this was your original graph. And let's say all you did was put a negative in front, like a -1. Well, a -1 wouldn't change the height. All a -1 would do is that. It would take the entire wave and flip it. So that's what an amplitude change looks like. Or we also can call that a vertical stretch. It's when you multiply by a number in the front. So once you multiply by a number, you are changing the height. If you want to know the new height, all you have to do is take the absolute value of whatever the number is in front. Okay, that will give you the new amplitude. So in this top one, we've got A for amplitude. What would be the absolute value? What would be the amplitude of that first one? Yeah, 3. That would be the new height. 3 means that it would go 3 units up and 3 units down. It would be a distance of 3 units at its farthest. Okay. How about this second one? What would be the amplitude of that one? Yep. 2. So does the negative have an effect on it? Yes, it does when you sketch it. But the negative has no effect on the amplitude. That one has an amplitude of 2. How about if I did that? What's the amplitude of that one now? Still 2. No change in the amplitude, but there is going to be a change when you sketch it. And how about the amplitude of that last one? 1/2. Yep. So there will be 2 or 3 questions on the test where I just say, what is the amplitude of the following? And you don't have to sketch anything. You just have to tell me the amplitude. I think I already mentioned that to you. Amplitude measures a distance, so it's always positive. So there's 2 different things that can happen with the amplitude. You can either stretch it and it gets bigger, or you can compress it and it gets smaller. If the number that you multiply by in front has an absolute value greater than 1, so numbers like 2, 5, 7.8, -12, any of the numbers that I just said will cause the graph to stretch. So if you want to think of it on like a number line, this is the zone where things stretch. Stretch, stretch. Any number in the green area. Numbers in the red area will compress. 0. Well, 0 wipes the wave out completely. 0.1, 1/2, 0.8, -0.6. Any number that's in that red area, the graph will compress. So, any question on when the graph stretches versus when it compresses? Okay, so I'm describing it to you more as like a picture here, and then I'm writing it out down below. All right. How about if I had something like what would be the amplitude of that? 3. This has nothing to do with amplitude. It has something to do with what we learned yesterday. It's a horizontal shift, but it does not affect the height at all. If you slide something left or you slide it right, is the height of the wave changing? No. Okay. So we got to make sure we know what number to focus on when they ask about amplitude. Okay. So now, if I am changing the height of that wave, think about, focus on like that coordinate right there. Okay. It's It's not going to stay on the wave. It's going to stay fixed, but the wave is going to move. If I take this wave and I stretch it vertically, what part of this coordinate changed when it went down there? Well, think about the coordinate has two parts. Yep, the y, yes. So today, that's why I said earlier, the y value is what is going to change. If the y's are going to change, then that means the x's are going to stay the same. So that means for every problem that we do in class today and on the homework tonight, the x's are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. There's the answer to the x's for every problem we do today. Okay, where did those x's come from? They came from the original table that I gave everyone yesterday. Two tables. All right, so how do we get the new y values? All we have to do to get the new y values is take the old ones and multiply by a. Notice it doesn't say absolute value of a. Okay. If the a is a negative number, you want to use it, because that negative is going to cause the graph to flip. So you multiply the old y values by whatever number is in front, and use the number the way it is. Okay. Only time you take the absolute value of that number is if I specifically say what is the amplitude. You don't want to give me a negative answer for that. Okay. That's different. That's pretty much it for amplitude change. Okay, so let's try a few examples. I could play a sound too. It's not overly interesting. It's just when you change the amplitude, it gets louder. That's all that happens. So the higher the wave, the louder it gets, and then it compresses. If it compresses, it gets softer. All right. So let's try this one. Okay, y equals 3 cosine x. All right. So first thing. How is that different from a phase shift? So we learned phase shift yesterday, and that's definitely different.
This changes like the y.
Okay, it changes the y. And what's different about the equation that tells you it's a phase?
It's not like inside with the x.
Okay, so one thing is that it's not inside where the x is. And what are we doing with the 3? What kind of arithmetic? Yeah, that's multiplication. When we did a phase shift yesterday, there was no multiplication. It was always adding or subtracting. Okay, so those are the two things that make this different. It's in front, so where we're doing it, and what we're doing. It's multiplication. It's not addition. All right, so we know we're going to keep which value the same in that table? X. And what are my original x's?
Isn't it? It's 0, pi over 2, pi, 3 pi over 2, and then 2 pi.
And then 2 pi. Yep. Okay, so those are the harder ones. We don't have to work with any of those today. Off to the side, I'm going to put my original y values. Okay. What are my y values for cosine? The original.
1, 0, negative 1, 0, 1.
Okay. So those are the originals. And what are we going to do to those 5 numbers?
Multiply by
Yep, multiply by 3. That's it. That's how you get your new y values. So just times them all by 3. All right, so that means my new y values are going to be
3, 0, negative 3, 0, 3.
Yep, that's it. That's how you get your new table. Any questions on the table? All right, Now, for the sketch, because I am scaling this, what could happen is if I multiply by a big number, that might mean I could go off my graph paper, okay, if I go by ones. So when I do a change in amplitude, I generally don't go by ones. Right? I don't want to have to get something that's 3 times as big of a piece of paper. So what I'm going to do is I'm going to change the scale on my y-axis. That way, no matter what problem you give me, it's going to fit on that grid right there. All I'm going to do is go by 3s instead of 1s on the y-axis. Okay. And that would be really handy especially if I multiplied it by like 30. Right? I don't want to have to draw the graph 30 times as big. So I just change my scale. What that means is basically every graph I do today is going to look the same because my scale is going to be changing. Okay. So I've got 0, pi over 2, pi, 3 pi over 2, 2 pi. You do want to put those labels on. If you don't put them, then it's assumed it's 1, 2, 3, 4, 5. And that's not what we're doing. Okay, so we got 0, 3. And we got pi over 2, 0. Pi right about there, I think, -1. Oh, no, I'm sorry, -3. 3 pi over 2, we're at 0. And then 2 pi, back at 3. That's it. That's your sketch. Just connected. Any questions on that? So now if you gave me a problem and it said to do 7 cosine x, I would draw exactly the same thing. I would just go like this. 7, -7. There's 7 cosine x. Right? That way I don't have to draw it 7 times as big. All right. So now with that, if we played that as a sound, would that be a louder sound compared to what we started with, or like a quieter sound? Louder, yeah. Would it be triple the volume? Well, maybe not. That gets into more like getting into decibels and how that works. But it would be louder. Yeah. Okay, so let's look at this one. 1/2 sine x. Okay, what's going to stay the same this time?
X.
Yep, x's. Okay, reason? There's 2 reasons. 1, you're not doing anything inside. Well, actually, there's 1 reason. You're not doing anything inside the x. That's why the x's stay the same. Okay. And the reason why this one is an amplitude change is because it is multiplication. Okay. We're going to do something else that's not inside the x in a minute. Okay. But it's not going to be multiplication by a number. All right, so let's write down our x's. And just a reminder why we pick those, they are all equally spaced. That's why we pick those. In degrees, that's 0, 90, 180, 270, 360. Gives us 5 nicely spaced points. All right. How about my original y values for sine? Yep.
0, 1, 0, -1,
0, 1, 0, -1, 0. So now we're going to take all those y values and we're going to multiply them by a half. Yep. So half. If it's easier for you to think of dividing them all by 2, well, it's the same thing. Just take half of them, divide them by 2, whichever way you want to think about it. Okay. So what are my new y values?
0, 1/2, 0, -1/2, 0.
Yep. Okay, be sure you copy the right table. Right? If you accidentally did the 1, 0, -1, 0, 1, then you're going to get all the y's wrong. And you'll probably get your graph wrong. All right. Questions on the table? Alright. Now I'm going to do the same thing I did last time. I'm going to scale my tick marks. I don't have to on this one. If I wanted to call this 1 and -1, I could. And then just kind of estimate a half is in the middle. But it's just how I do it. So 0, pi over 2, pi, pi over 2, 2 pi. Okay. And now graph your points. So sine wave, generally that's the one that if you don't shift it left and right, it starts at the origin. If you shift it left or right, then no, it will not. Or possibly it will not. So pi over 2, pi, 3 pi over 2, and 2 pi. Yeah, some people find that one easier to draw just because of the way the wave goes. And the cosine one, they just have a little harder time with it. But you're drawing the same thing. Remember, it's just the section. You're drawing that. That's generally how the cosine one looks. Or you're drawing something more, like that. That's kind of how the sine one looks. All right. Any questions on that? All right, let's try one more, and then we'll look at our last transformation. What are we multiplying by in front this time? -1. So is there really going to be a change in the amplitude? No. There's not a change in the amplitude. But it's going to flip it. Okay? We can still treat this using the same steps we did for the other problems, even though there really is no change in the amplitude. Okay, what column stays the same? X, and what are my x's again?
Pi over 2. 0.
Yep, 0.
Pi over 2. Pi. 3 pi over 2.
Okay. Original y values for cosine.
1, 0,
Okay. And what are all of those going to get multiplied by? -1. Yep. So I'm just going to do it right here. So no change in amplitude, just flipping it. Okay. And that's it. That's your table. Any questions on the table? Now this time for my y-axis, I don't really need to scale anything. I could leave those unlabeled if I want, because I'm going to go by ones. If you want to label them, then that's how I would label them. Hey! Bless you.
Hey!
Bless you.
Thank you.
All right. Let's put in your labels for your x-axis. Make sure you put them low enough. I'd probably put them a little high. That should be fine. Okay, so 0, -1. Pi over 2, we're at 0. Pi, we are at 1, 0, and right about there. So normally when you draw cosine, it looks more like a U shape. This one's going to be flipped over and look more like an N shape. It's just part of the wave that we're sketching. Any question on that? It's like a ghost. Yeah, any question on that? All right, so that's your amplitude change, right? Stretching and compressing, also causing a flip. Okay, the last one we're going to look at is a vertical shift. So this one is connected to yesterday in the sense that it's going to move it, not stretch it, but it's going to move it up and down. When we moved left and right yesterday, we did it inside the parentheses. And what operation did we do to move left? We did plus, yep. And which operation did we use to move right? Subtraction. So we always used addition or subtraction. Okay, that was the point. Any vertical shifting always uses addition or subtraction. Okay, so here's some examples of vertical shifts. Okay, the reason you know that they're vertical and they're not horizontal is because they are not in parentheses with the x. The only way you could make this into a problem like we did yesterday is if you did that. Now, it's inside parentheses with the x. That is a phase shift. That is a vertical shift. Okay. One of these is up and one of them is down. Which way do you think the +2 would move the graph? Yep.
Up.
It would. It would move it up. Okay? And if you're thinking, well, wait, when we talked about phase shift yesterday, it was backwards. It was. Today, it's not. Okay? So when you do a vertical shift, it is not backwards. And that, I kind of want to just show you on the calculator. Okay, so let me graph sine of x and sine of x plus 2. So watch where the red one is compared to the blue one. The red one had a +2. So it draws the exact same wave. Everything's just moved up 2 units. Okay. Any question on that? All right, so let's write that down. So vertical shift, it moves it up if you add and down if you subtract. Okay, if you have a hard time remembering that, then I would make sure you put that on your reference sheet. Because you don't do the opposite. All right, so once we know what it looks like in the equation, it's adding or subtracting a number on the end. You could also see it like this. I generally don't do it this way. That's exactly the same thing. Think about doing like 4 plus 2, 2 plus 4. You're adding two things together. You can switch the order. But I generally will do it this way. So the next thing to look at is what column is going to change. So think about if you had that wave and you have a point on it. If we take that wave and we shift it up, that point goes from here up to there. What part of the coordinate would have to change to make that point move from there up to there? Yep.
The y coordinate?
The y coordinate, yep. The x coordinate would stay exactly the same. So just like we did in the last transformation, copy the x's down from your original table. Okay, there's no change. And that's also why we're doing two transformations together, because the arithmetic on these is very easy. It's with ones and zeros. So that's why we get them both out of the way at the same time. So x's stay the same. Now for the y's, all you have to do is take the number that's at the end, which I called d. Take the number that's at the end and add or subtract it to the original y values. But don't do the opposite. So if you see a problem with a +2 in it, do a +2. If you see a problem with a -3, do a -3.
Could you scroll up a bit so I can read that part?
Good.
Thank you.
Okay, and just a reminder for anyone who wasn't here, we always pick 5 points because that makes it very straightforward to do the graph. If you only pick 1 or 2 points, that's not enough. Okay, you need about 5. You could do more than 5. We usually do 5. So this particular transformation, I can't really demonstrate with sound. I don't really know of a connection between taking a sine wave and shifting it up or down. Stretching it up and down, yes, that's volume. Moving it left and right, that's the phase. Heard that earlier. But this one I can't. The last one we're going to do tomorrow, I can. Okay, so we'll save that one for tomorrow. And that's probably the most interesting one, what you can do with that with sound. All right, so let's try that. Y equals sine of x plus 2. Okay, so now we know 3 out of 4 of the transformations we're going to learn this week. So first thing we have to do is identify which one that is. Okay, on the test, they're all going to be mixed up. Okay. What, out of the 3 we've learned, what kind of transformation is that one, and how come? Yep.
It's vertical shift.
Yep, definitely a vertical shift.
Why? Because it's not in parentheses.
Okay, because you're not doing something inside here. So not doing something inside means it's definitely vertical. But why is it a shift and not a vertical stretch? Yes?
It's addition.
It's addition, yep. So to figure out the kind of transformation, you look at 2 things. Where it is and what it is. Where is it? It's outside the parentheses. What is it? It's addition. Addition outside means vertical shift. All right, let's make our table. We're going to be shifting vertically. So which column is going to stay the same?
X's.
Yep, x's stay the same. So I'm going to write those down. Okay, hopefully you're starting to get familiar with those because we use those numbers a lot. All right, original y values for sine are what?
0, 1, 0, 0.
Okay. And what are we going to do to all 5 of those? Add 2. Don't do the opposite. And that's going to take your graph and shift it up 2. In fact, I think that's the one I already did a graph up for you. Oh, no, I might have shifted up 3. 1, 2. No, that was 2. That actually is that one. Okay, so what are my new y values? Iliana?
2, 3, 2, 1, 2.
Yep, 2, 3, 2, 1, 2. Okay, any questions on the table? All right, so let's put our labels. Because I only shifted up 2 units, I'm going to go by 1s on the y-axis. That gives me plenty of space. On the x's, it's fine to put my labels right up against the axis because I know I'm not going to draw there. I shifted up. So I'm going to put my labels right near the tick marks. All right, and I've got 2, and we're at 3. Pi, we're back to 2. 3 pi over 2, we're at 1, and back to 2. There's your sketch. Okay, now, let's say I ask you for the amplitude. What's the amplitude of that graph?
3, 3.
No. Yep, it's 1. So remember, the amplitude is the distance, like if you draw in this imaginary center line. It's the distance the wave is off that center line, okay, which is just 1. If I asked you what is the highest y value that the graph ever hits, what would that be? That would be 3. Okay. Everyone understand the difference between those 2 questions? Okay. Anything else on that one? try one more. We did a sine function with a shift. Let's try a cosine. Now this one has parentheses. So does that make this one a phase shift? Why not? I thought parentheses made it a phase shift. Yeah?
Because the cosine and x are there. The x isn't
Right. It's not just having parentheses. It's having the x and the 5 in parentheses. Like this. That's a phase shift. Okay. That's different. Just putting parentheses like that, those parentheses effectively do nothing. Okay. If you put parentheses like that, or you could also see it like this, same thing. Those are both shifting down 5. All right, let's make our table. So the last one, which column stays the same? Yep, x stays the same. Okay, what are my y values one more time for cosine? Just the originals.
1, 0.
Yep. 1, 0, negative 1, 0, 1. And what are we gonna? How are we gonna modify those to shift them down 5? Yep.
Subtract 5.
Subtract 5. Okay. So when I subtract 5 from all of them, what will I get? Yep. Leon?
-4, -5, -6, -5.
Yeah. Yeah, perfect. Okay. Any questions on the table for that one? Okay. So the last thing is the sketch. Because I'm shifting down 5, I can put my labels. Whoops. Not like that. 0. Put all my labels right there. I won't have any problem. Just see if I put enough. Yep, exactly enough. All right. So first coordinate is 0, -4, pi over 2, -5, pi, we're at -6. So we've hit the bottom of the V. Now it's going to start coming back up. And there's your sketch. Okay. Any questions on that? All right. So that's the vertical shift and the amplitude change. So homework tonight, pretty much the same kind of thing as last night. It's a worksheet on Schoology. So you just click on that, and then there's, I think, 5 questions just like last night. You've got about 12, 13 minutes